हॅलो फ्रेंड्स, लास्ट लेक्चरमध्ये आपण बघितलं एक्सपेरिमेंटल मेथड्स इन एक्स-रे, लवे मेथड. सेकंड was which method? Second was rotating crystal method, and third was Debye-Squirer method, that is powder method. Now in this lecture we are going to see analysis of cubic structure by powder method. How to analyze the cubic structure of the sample by using powder method. Now, so we know that in powder method there is a Debye-Squirer camera, in which at the center of the camera there is a powder sample. At inside that camera there is a photographic film which is coated in circular manner inside the camera, and X-rays are incident on that powder sample. Okay. Now suppose in this method we use the monochromatic X-ray. Suppose the X-ray of wavelength lambda is incident on powder sample. Of cubic crystal. Suppose we have a powder sample of cubic crystal. How to analyze? We are going to see here how to analyze that cubic crystal structure of that powder sample. Now suppose L1, L2, L3 are be the distance between symmetrical lines on the photographic film. And theta 1, theta 2 and theta 3 be the corresponding angles of diffraction respectively. Now suppose we know that the interplanar spacing between two parallel planes having Miller indices HKL for cubic crystal which is given by DHKL equal to A upon under root of H square plus K square plus L square. हे आपण मागे बघितलेलं आहे. DHKL for cubic crystal, DHKL equal to A upon under root of H square plus K square plus L square, where A is the lattice parameter, H, K and L are the Miller indices for that particular plane. And according to Bragg's condition or Bragg's law, 2d sin theta equal to n lambda. Therefore we can write here d equal to n lambda upon 2 sin theta. Now here this is suppose equation 1, this is suppose equation number 2. Now from this two equation, the interplanar spacing left hand side is equal, therefore right hand side should be equal. Therefore from 1 and 2 we can write n lambda upon 2 sin theta equal to A upon under root of H square plus K square plus L square. That is, this can be simplified as take the square on both sides. That will we get n square lambda square. हा टर्म इकडे घेऊन घेऊ म्हणजे आपल्याला मिळणार h स्क्वेअर प्लस k स्क्वेअर प्लस l स्क्वेअर इक्वल टू स्क्वेअर केलेला आहे म्हणजे 4a स्क्वेअर साइन स्क्वेअर थिटा. Now suppose let n square s square plus k square plus l square equal to suppose capital N. Therefore this equation can be written as n lambda square equal to 4a square sin square theta. Now in this we have use here n square s square k square plus s square. N is the integer which represents the order, s k l also the integer, s k l the lattice parameter is 1 0 1 1 2 and so on. Therefore this represents the number. We have taken that number as n. Therefore we get n lambda square equal to 4a square sin square theta. If we rearrange this equation, we can rearrange like that: sin square theta upon n equal to lambda square upon 4a square. Lambda square upon, that is 4a square. As we are considering here the powder method in which the x-ray is monochromatic, that means that x-ray is constant. A is the lattice parameter which is constant. Therefore the right hand side of this equation represents the constant quantity. Therefore that is we can write here sin square theta upon n equal to constant. Now suppose, for example, suppose we consider a case in which, suppose let we consider a case in which the wavelength of X-ray is suppose 1.3 Armstrong unit, and glancing angle, that is Bragg's angle, theta 1 equal to suppose 19.2 degree, theta 2 equal to 27.72 degree, and theta 3 equal to 34.73 degree. For parallel planes having interplanar spacing d1, d2 and d3 respectively. सपोज त्या क्रिस्टलमध्ये आपण कन्सिडर करतो तीन पॅरलल प्लेन्स ज्याचं ते तीन पॅरलल सेट ऑफ प्लेन्स ज्याचं इंटरप्लेनर स्पेसिंग आहे d1, d2, d3 आणि त्याच्यावरून जे डिफ्रॅक्शन होते ते या पर्टिक्युलर अँगल करता होते थीटा 1 इक्वल टू 19 पहिल्या प्लेन करता पहिल्या सेट ऑफ प्लेन करता थीटा 2 इक्वल टू 27.72 and theta 3 equal to 34.73. Now to find the constant A, let's consider a tabular form as, suppose we consider a tabular form like this as, suppose capital N value is suppose capital N, again this sin square theta upon N, theta 1 equal to 19.2 degree, theta 2 equal to 27.72 degree, and theta 3 equal to 34.73 degree. Therefore if we use the sin theta 1 value is 19.2 degree, therefore the sin theta 1 must be equal to 0.3289, and obviously sin square theta 1 must be equal to 0.1082. Similarly here sin theta 2 will be 0.4651 and sin square theta 2 must be equal to 0.2163. Similarly theta 3 sin theta 3 must be equal to 0.5697 and sin square theta 3 must be equal to 0.3246. Now suppose we draw a table like this. And suppose the value of n is suppose 2, 3, 4, 5 and so on. Therefore, the value of sin square theta upon n, जे आपण इक्वेशन काढलं sin square theta upon n, sin square theta यामध्ये ह्या कॉन्स्टंटची व्हॅल्यू आपल्याला फाइंड आउट करायची आहे. तर याकरता सपोज n इक्वल टू सपोज 2 असेल आणि sin square theta इक्वल टू theta 1 इक्वल टू 19.2 असेल, त्याच्याकरता sin square theta ची व्हॅल्यू होऊन जाणार 0.0541. If we calculate this, we get this value 0.0541. त्यानंतर जर θ2 ची व्हॅल्यू 27.72 डिग्री असेल तर sin square theta upon n ची व्हॅल्यू फॉर n इक्वल टू 2 विल बी इक्वल टू 0.1081. आणि त्याच पद्धतीने θ3 करता आपल्याला मिळते 0.1623. Now from this table, suppose we have sin square theta upon n. The value of this constant is suppose first for theta 1 equal to 0.0541. Therefore, we have from our previous equation sin square theta upon n equal to lambda square upon 4a square. Therefore, we can write therefore lambda square upon 4a square equal to 0.0541. And from this equation we have the value of lambda. For consideration we have taken lambda equal to 1.3 Armstrong unit. Then from this equation we can find out here a square equal to 7.81. By using the values of lambda and by calculating this, we can find out a square equal to 7.21. That is, from this equation we get a must be equal to 2.79 Armstrong unit. 2.79 Armstrong. Now from these values, interplanar spacing for a particular set of parallel planes. Now interplanar spacing for, that is interval spacing आपण रिप्रेझेंट करतो d ने, d for particular set of parallel planes having Miller indices HKL can be obtained as we have the equation d HKL equal to a upon under root of s square plus k square plus l square. This is for cubic crystal. Okay. Now for suppose 100 plane. Therefore for 100 plane, d100 can be expressed as a equal to, we have find out a equal to 2.79, that is 2.79 upon under root of obviously 1. So for 110 plane, d110 can be expressed as 2.79 upon under root of 2. And for 111 plane, d111 can be expressed as 2.79 upon root 3. 2.79 upon root 3. If you solve this, we get this 2.79 Armstrong unit. If you calculate this, you get 1.973 Armstrong unit, and similarly we get here 1.61 Armstrong unit. Now if you take the ratio of these three planes, suppose this is suppose d1, d2, d3, if we suppose say that, then we get, if we take the ratio d1 as to d2 as to d3, we get here 1 upon root 1, that is equal to root 1, or 1 upon root, that is equal to 1, as to d2 is 2 upon 7, that is root 1 upon root 2, as to 1 upon root 3. If we taken this equation similar as it is and divide that total equation by 2.79, we get only root 1, that is 1 upon root 2 and 1 upon root 3. Okay. Similarly, from suppose this is equation number 3. Now from interplanar spacing equation, we have DHKL equal to A upon under root of h square plus k square plus l square. That is, therefore, for 1 0 0 plane, therefore D1 0 0 can be expressed as A upon 1 0 0, that is equal to root 1. Similarly, for 1 1 0 plane, that is D1 1 0, it will be represented as A upon root 2, and for 1 1 1 plane, D1 1 1 can be expressed as A upon root 3. That is the ratio can be expressed as, suppose D1 h2 d2 h2 d3 will be equal to A upon root 1, A upon root 2, A upon root 2 divided total equation by A. We will get here root, that is 1 upon, that is 1 h2 1 upon root 2 h2 1 upon root 3. This is equation number suppose 4. Now this interplanar spacing or these values of d1 d2 d3 can be confirmed by the Bragg's condition, that is the Bragg's law. These values of d1 d2 and d3 can be confirmed by Bragg's condition or Bragg's law, which is 2d sin theta equal to n lambda. Now we have 2d sin theta equal to n lambda. Now for first maxima, this equation can be written as 2d sin theta equal to n equal to 1. For first maxima, n equal to 1, that is equal to lambda. Therefore, for diffraction for three planes, that is plane 1 0 0, plane 1 0 0, plane 1 1 1 1 0, and plane 1 1 1 1 1, we can write this equation as for three planes as lambda equal to 2d sin theta 1 and d1. Lambda equal to, lambda is constant, it is the monochromatic X-ray in powder method. Therefore, we get for another set of plane, we get lambda equal to 2d2 sin theta 2 and lambda equal to 2d3 sin theta 3. Okay. Now if we take the ratio of d1 h2 d2 h2 d3, we can write d1 will be equal to lambda upon 2 sin theta 1. This is d2 equal to lambda upon 2 sin theta 2. Here d3 equal to lambda upon 2 sin theta 3. If we divide total that equation by lambda upon 2, we get here 1 upon sin theta 1, 1 upon sin theta 2, 1 upon sin theta. Therefore, it will be 1 upon sin theta 1, h2 1 upon sin theta 2, h2 1 upon sin theta 3. Okay. And if we solve this, we have the values of sin theta 1, sin theta 2 and sin theta 3 as 0.3289, 0.4651, 0.5697. If we use these values in this equation, we get 1 upon 0.3289, h2 1 upon 0.4651, h2 1 upon 0.5697. And if we solve this, we get 3 h2 2.15, h2 1.75. If we divide this equation by 3, we get here 1 h2 1 upon root 2, h2 1 upon root 3. This is d1 h2 d2 h2 d3. This is equation number 5. Now from these 3, 4 and 5 equation, we can say that this structure is simple cubic structure. Therefore, from equation 3, 4 and 5, we say that the given structure is simple cubic structure. आपण सिंपल क्यूबिक स्ट्रक्चर मध्ये आपण मागच्या काही लेक्चरच्या अगोदर बघितलेलं आहे D100, D110 and D111 is equal to 1:1/√2 1/√3. ओके. अशा पद्धतीने आपण कोणत्याही स्ट्रक्चरचं क्युबिक स्ट्रक्चरचं आपण ॲनालिसिस करू शकतो आणि त्याच्यावरून ते स्ट्रक्चर कोणत्या नेचरचं आहे आपण हे फाइंड आउट करू शकतो बाय युजिंग द पावडर मेथड. ओके.